Okay, let's talk about the Green Revolution. This is a term that a lot of people haven't even heard of, yet it's been enormously important on the world scene. Has really transformed the way the world deals with food, is in large part responsible for the reduction in hunger around the world, even though it's still a problem. Certainly progress has been made on that. And the Green Revolution is the primary reason. So let's start earlier in history and discuss where the concept came from and why the world needs to worry about these issues, and how big foundations and world governments have become involved in that. In 1798, there was an important document created called the Essay on Principles of Population by Malthus. He talked about how population increases and how the food supply increases, and raised alarm that population at one point, in fact he thought it would be soon, would outstrip the world's ability to create food. And what he said is that the food supply increases arithmetically, but that population increases geometrically. And that if there was balance between food supply and the population back when he was writing about it, or perhaps even some abundance, that would soon give way to the stark reality that population would increase in a way that would outstrip the food supply. And so here he's quoted in this essay as saying, the power of population is so superior to the power of the earth to produce subsistence for man that premature death must in some shape or other visit the human race. Now he was correct in noting that hunger was going to be a problem, but not for the reasons he thought. And so according to his idea, you'd expect a function that looks over time to be like this, that you'd expect the food supply to increase at a rate like this, but population to go like this. And so he projected that if you're out here, you're okay, but once you start to get into this territory, things wouldn't be okay. In fact, that's not the way the curves actually look. So if you look at time, going back even before 1300 and then go up to the projections for the year 2020, the Food and Agriculture Organization has created this plot. Now I'm sorry this isn't the crispest of graphs, but the lighter colored line here is the food supply and the population is in the red line that goes here. So this is quite different than what Malthus projected, and the question is why? What's gone on to explain what the model would have suggested and what the reality actually was? And what he couldn't anticipate at that time were a number of things. One is technology advances that made growing more food readily possible around the world. Birth control became an issue because he was making projections based on assumptions that there wouldn't be modern methods of birth control, and then he couldn't predict that there would be a green revolution. Those things combined have changed the plot of the graph to the point where we get the function that we do now. Now the Green Revolution has been a really important player in food history, but it's collapsed in a relatively short period of time given the evolution of major changes in agriculture around the world. So you can see going back, hundreds and thousands of years about what happened with different parts of the agriculture revolution, where agriculture, the domestication of animals that we talked about before, the specific cultivation of crops came in at one point. Those were major advances. But those took a long, long time to kick in. In fact, the Green Revolution has happened over only a period of about 45 or 50 years. So very impressive changes in a short period of time, and of course technology, globalization has made that possible. This is necessary because the world's population is growing at a very rapid rate, and the world needs more food to survive. And the chart shows just how much different parts of the world are going to have to increase food production just in order to support the populations. So the United States, given how much agriculture it has, the world's largest producer of corn, for example, is still going to have to make a 30% increase in the United States and Canada, increase by 30% to help feed the people that are part of the population increase in those two countries. And then you can see the numbers are very high in Asia and Latin America as well. Latin America, an 80% increase in food production to support the population. That's a lot. But when you get out to Africa, the numbers are really very high. And it so happens, as I'll talk about later, that Africa is the part of the world least touched by the Green Revolution. So some problems definitely need to be solved. So today we're going to talk about the definition, history, what the Green Revolution is, and then its impact. And the impact is highly controversial. On one hand, the proponents of the Green Revolution make a very strong case that world food productivity has increased an awful lot, that this has helped solve, to some extent, the world's hunger problem, and that this is absolutely necessary for the stable function of human beings. The critics of it say that that's all fine and good, and those are important goals, but there are some negative consequences of the Green Revolution that most people haven't considered, but need to. So we'll talk about both sides of this issue. So what is the Green Revolution? Well, it's basically the desire to increase the yield and decrease the amount of farming that's done around the world so that people can have more to eat. And so the word yield is an important concept in this context. It basically refers to how much productivity are you getting out of a certain amount of land. So if you're producing X bushels of wheat in Y area, and then you increase the yield from the same area to 2x, then that's considered a good thing. And so a lot of the Green Revolution focuses on yield. And these are the primary ways that the Green Revolution has sought to do that. Irrigation becomes a very important issue, and you can greatly increase in certain parts of the world the amount of crops you can grow by irrigation. In fact, in some parts of even the US, you simply can't grow crops unless there's irrigated land with water brought in from other places. Fertilizers become a major issue and of course increase yield. Pesticides increase yield because the crops aren't getting eaten so much by other things. And then there's technology and biotechnology that's involved here. And then part of the whole Green Revolution, and this is probably the most controversial part, but not the only one, is the genetic modification of foods. Because you can genetically modify crops to have certain properties that will increase yield, make them more resistant to drought, more resistant to certain pests, etc. And those have become a big player in the Green Revolution. The critics of this say you're releasing something that could be pretty disastrous on the world. That is these genetically modified crops, and we don't know what they're going to do to the ecosystem. We don't really know what they do to human beings, et cetera. So there's some people that are pretty alarmed about that part, where others say that this genetic modification is absolutely necessary and vital part of the Green Revolution. The term itself was introduced in the 1960s. There's some controversy about who came up with the term first, but some reports that I've seen suggest that this individual is the one who first coined the term Green Revolution. The concept existed before then. People were doing things that, and you'll see examples of that back in the 1940s, that were consistent with the concepts of Green Revolution, but the term didn't come about till later. So the hope here is to reduce and eliminate hunger, equip the world for the rising population, and more or less to feed and clothe the world. So the companies that benefit from the Green Revolution, the biotech companies, the agribusiness companies that sell the genetically modified seeds, that sell the fertilizers, sell the pesticides, basically talk about the wonders of the Green Revolution, feeding and clothing the world. There's debate about how it's accomplishing that, but that's the hope at least. The whole concept of the Green Revolution really got its impetus and its initial birth from the Rockefeller Foundation. Headquartered in New York City, the Rockefeller Foundation, back in the 1940s, decided that world hunger was a massive problem and wanted to intervene, and then created a program that really spurred the Green Revolution. It so happens that the current president of the Rockefeller Foundation, Judith Rodin, was a professor in psychology here for some time, then she was provost at Yale, was then the president of the University of Pennsylvania, and is now as president of the Rockefeller Foundation. So there are some Yale ties there with Judy Rodin. The person who's considered the pioneer of the genetic revolution is a man named Norman Borlaug. Borlaug was a chemist with DuPont, the DuPont company, but got brought aboard by the Rockefeller Foundation in 1944 to spearhead this effort of the Green Revolution. He made an enormous difference in the world, and he led teams of investigators and scientists to go around the world and use new strains of crops, especially wheat, look at new growing techniques of biotechnology and things that existed at the time to increase the productivity in these areas. Here's a, let's see if we can get it to go. Here's a picture of him later in his life. He's very well known for developing this disease-resistant strain of wheat. And I'll give you some examples with cotton of that concept. He started with Mexico, but then went to Pakistan and India, made very large differences in these countries because the Mexican experiment that went first was considered such a success, and he was awarded the Nobel Prize in 1970 for this work. There are key moments in this, and Borlaug was instrumental in all of them. In 1945, the Green Revolution, as I mentioned, began in Mexico, and it was especially driven by changes in wheat production. And the population was rapidly growing in Mexico at that time. Borlaug and others helped develop healthier strains of wheat that could resist the various threats to it, and as a consequence, the self-sufficiency of the country of Mexico went way up. Some years later, building on that success, as I mentioned, Borlaug and others took the Green Revolution to India, where mass famine was occurring at the time, and tried to increase rice yields by the use of different strains of rice that people called miracle seeds at the time. So these were a couple of landmarks in the Green Revolution. The major focus of this, as I mentioned before, was to increase the use of pesticides. Now you can start to guess about what some of the concerns about the Green Revolution might be when you're starting putting more chemicals on farm fields. But if pests are devouring crops, lowering productivity greatly, and people are starving, then pesticides become a necessary part of that picture. Increase the use of fertilizers for obvious reasons. That has the same set of concerns that it generates, but the same set of opportunities. The irrigation we'll come back to in a minute, and the word cultivars has to do with changing the nature of the seeds that you plant. So what you're cultivating can change, and that itself can increase productivity. So what gets put in the ground becomes part of it, the seed part of it, and then what's done to it afterwards becomes part of the picture as well. And the goal is to do these things, and here's where the word yield comes in, but the word yield has a number of different components. So increasing the number of acres being farmed around the world becomes an important priority because, of course, that's one way to increase food output. They want to have fewer people. One of the aims was to have fewer people involved in producing food because that means that you're able to produce the same amount of food with less labor, and that increases productivity. Now you can begin to think about some of the concerns with that. America, as we'll talk about later, used to be a nation of a great many farmers with relatively small areas they were farming. The number of farmers has gone way down in a short period of time. I'll show you graphs on this later. But the number of acres per farm has gone way up. And so that's where you get into to factory farms. They're called vast acreages that are used for raising animals or for growing crops. So the productivity per person effort has gone up, but the number of people involved has gone down. And the critics of this phenomenon, this trend, have talked about how farming has become big business. We're more detached from food. Political issues political power of the big farming institutions are driving food choices and driving nutrition policy in the US, et cetera. So that's one of the downsides of it potentially. If crops mature earlier, then of course a single unit of land can produce more crops more often. Better response to the fertilizer, so if you genetically modify the crops or systematically breed them to be more responsive to the fertilizers, and potentially at the same time more resistant to pests, then of course you can increase productivity. And these other things are pretty self-evident. So there are a number of different pieces about the Green Revolution. So if you really get down and say, what is it supposed to do? What are the things it's supposed to do are all these things. And you can see how many different inputs would be necessary to produce these. Fertilizers, pesticides, irrigation, genetic modification of foods, all these things are necessary. So I'll give you two examples of the Green Revolution in action, and we'll talk about some of the consequences of these. So one would be a technology advance, which is the use of irrigation, higher use of irrigation. And then we'll talk about biotechnology and genetically modified foods. It's a very interesting issue. And we'll come back in a later class and loop back to some of the concerns about the genetic modification of foods. But for the most part today, we'll talk about the upside that is part of the Green Revolution. So the early technology advances that have been made, some of them are interesting, and there will be familiar names you're going to see associated with some of these. So in the early 1700s, one major advance was from this man whose name is Jethro Tull. Now some of you who like rock music may recognize the name of a rock band that was popular in the 60s and in the 70s to some extent. But Jethro Tull himself got famous for making this seed drill, which was a mechanized way of planting fields. In 1831, this fellow became prominent in the whole agriculture world. His name was Cyrus McCormick, and you may remember from high school history that he was credited with developing the reaper, which was a way to harvest the crops and to greatly increase the efficiency of a farmer being able to harvest things, especially wheat. In the 1830s, this man became popular. His name was John Deere. He was famous for developing a particular plow, a steel plow, made a company out of this, and then of course we all know the John Deere company of today. So these people were important players. A particularly interesting bit of technology has to do with irrigation. If you think about the fact that we're growing vast amounts of crops in pretty arid land in California, for example, lots of the vegetables and things that are grown in California are grown in pretty arid land, and irrigation is necessary to make them grow. You get a picture of what might be involved in the water resources necessary to grow our food. And where does this water come from the most part? Well, water in these sort of places, or in some of the arid areas, is not necessarily pumped from the ground. It is not part of the local ecosystem, but is basically brought in from outside. And so you probably heard some of the debates over the years about water that is in the Colorado River that gets funneled off to various places in the West, like Las Vegas, not for growing crops, but just for supporting the city, to California for growing crops and the like. And then places get in water wars about this, and the cost of water, and who has to pay for it. Does the government subsidize it? These all become issues. But as I'll mention in a later class, the depletion of natural water stores is a major concern in certain parts of the world, a major concern. So the amount of water that we're using for agriculture has a downside, but also an upside, of course, because it greatly increases productivity. There are lots of types of agriculture. Those of you who have flown on airplanes between here and the West Coast, when you get to the Colorado area, in other parts of the West, you'll see the irrigation that you see on the right, which are these big circles where you have irrigation coming out from the middle in these big machines that provide it in circles, but other places have different kinds of irrigation. There are many different types. Irrigation is done in different ways. So if the water is to be drawn from a local resource, here would be an example of that happening, that you'd have some kind of a holding area like over here that would be a lake, a spring, or something that was generating water. Maybe it would have to be brought in from the outside. But then there would be these piping systems, there would be pumps in different places, and that would deliver the water to the various parts of the farm. And then there are smaller versions of this too, where there might be a holding tank for water used in smaller plots of land, but all driven by a power type thing like a pump. So that would be when the water has to be moved from one place to another. There's some places where gravity will work. The water's coming down from a mountain, let's say, an irrigation system is brought up. There are little trenches built in various places, and the water gets funneled off into the farm, but mainly it's pumped in different places. So there's an energy cost of that as well. So when you think about how much energy it takes to grow specific crops, and when we talk about sustainability, we'll start to talk numbers with that, then the amount of energy it takes to bring water from one place to another is part of that overall picture. In the developing world, irrigating crops becomes very important because, of course, some of these areas are quite prone to lack sufficient water to grow these crops. So there's a particular type of well that very often gets used in these areas called a tube well, and you see a diagram of it on the right and people creating one on the left. They're easy to do. You just have to drill a hole, go down and find a water source, and then pump the water up with a pretty inexpensive little pumping system. It can be done by hand, or it can be done mechanically or with a pump, but one way or another the water can be brought to the surface. Now, one of the questions is how clean the water is that gets brought to the surface, and I saw a statistic just the other day that there was concern in Bangladesh in particular that the aquifers that are being tapped into by these water sources are pretty high, and some of them are pretty high in arsenic. So the cleanliness of the water becomes an issue. But for the most part, it's considered a good thing when people are given the technology and the resources to drill these kind of wells, because then they can generate water to help support their crops. Here an example of tube wells on Pakistan on the left and Bangladesh on the right. So these would be small wells that can generate some water, enough to irrigate a small amount of land. And if you install some kind of electric pump, then you can generate even more water. Irrigation in some parts of the world, and as I mentioned, some parts of the United States, are absolutely necessary to grow crops. So for example, here would be irrigation in Arizona where lettuce is being grown. Now, those of you who have been to Arizona know that it's not the most hospitable climate in which to grow crops. In fact, if you see the Arizona landscape across a large part of the state, you'd be amazed that anything could grow there at all except cactus or things like that. But the fact that you can grow lettuce in Arizona is made possible by irrigation, and that's made possible in part by government underwriting of the water. So you can imagine that it costs a fair amount of money to get water to a field like this, how quickly it would evaporate in that dry Arizona climate, the hot, dry Arizona climate. So there's a lot of places where the water just evaporates into the air. And so the cost is really quite high to irrigate a crop like that. But it's made possible and becomes cost efficient for a farmer to do that only if the government is helping buy the water. So some people are saying government shouldn't be involved in buying the water, that it's subsidizing crops and it leads to growing crops where they really shouldn't be grown. That Arizona is not a very good place to be growing lettuce. You should find some other place that can grow lettuce without the great use of water resources, etc. So is this kind of thing good or bad? Well, it really depends on your perspective. If you're concerned about depletion of water resources, government subsidies underwriting growing crops in places like that, you wouldn't like the idea. If you want people in Arizona to be closer to their food and to have a local source of food supply, then this is a pretty good idea. And so it really depends on where you sit on this kind of thing. But it's interesting to think about what it means to grow lettuce in Arizona. Now, lettuce in Arizona is not as important to the health of the country as growing some sort of a vegetable in a poor country would be, where they absolutely need the agriculture and the irrigation to survive. So in the US, this process could happen in another location, but that's not always true in other countries, and so the irrigation becomes more important in some areas than another. But as I mentioned, one hot political issue is the use of the water from the Colorado River. A lot of the water that comes from the river is snow runoff from the Rocky Mountains and from other places that are tributaries feeding into the river. And there's a great deal of water in the river, but there's a great deal of demand on the water in the river, and that creates lots of political disputes. So the Arizona River then has been dammed in certain places. Large use of its water for irrigation takes place, and so you see things like this, which would be an irrigation channel that's drawn water from the Arizona River, and then it gets distributed to various farmers. So when we come back to this particular lettuce farm in Arizona, raises a lot of interesting issues, as I mentioned before. Is it good, is it bad? Well, it really depends on how you look at it. I'm going to show you some graphs of increasing productivity that's been produced by the Green Revolution around the world, but some of these graphs are expressing yield per unit of farm land. And the typical unit that we use in the United States is acres, but that's not the unit used everywhere in the world. And so this concept of the hectare is an agricultural concept. And so some of the graphs you'll see will be the amount of production per hectare rather than per acre. So you can see what the conversion here would be. So here's an example of the kind of thing that the Green Revolution may have produced. In this case, the effect of irrigation on the production of tea. And the graph looks like this. As you go from less on the left to more irrigation on the right, and the yield up on the y-axis there, you can see as there's more irrigation, you have higher yields of tea. So there's a pretty clear relationship here. And the world can calculate what the benefit is. What's the cost of this in terms of water depletion, cost of pumping the water in different places, and what do you get from it in terms of the tea yield? And then people can come to their own conclusions about whether it's worth it or not. But there's some interesting things in this graph. So if you look to the left, here's what you get with no irrigation at all. Here's big returns from increasing irrigation in that part of the graph. But then you hit a point of diminishing return out here where you're not getting much additional return for much more water. And so these kind of calculations have been a long part of the farming system. People understand what they are and try to do the best to yield cost benefit. It's very similar, for example, to calculations that people make about how long do you allow a nursing cow to feed its calf. Because the milk that the cow is producing is valuable in the marketplace, but of course it's important to the well-being of the calf as well. So the farmers have very precisely calculated the exact day you should stop the nursing and start having the calf feed from other sources and allow that milk to go to market. So those are the kind of calculations that farmers make all the time, and farming has become a very scientific enterprise. I know at least a couple of you have told me that you grew up on farms, and it's very interesting to learn about that kind of thing and how scientific it really has become. So the irrigation works, there's no question about that. The graph I showed you before with the tea is an example of that, but I could show you graphs of lots of other crops as well. But is it worth the cost that we pay to do it? But most important is, will the water last? And there are very serious concerns about what's happening to the depletion of water resources around the world, even in the US. And I'll show you a chart in a later class about a particularly large aquifer in the Midwestern part of the US that has been an important source of water supply for crops all around the US that is projected to run dry in a certain number of years. So the fact that we're drawing so much for the food becomes an interesting issue. All right, let's talk about biotechnology and genetically modified crops. As you can guess, the whole concept of a genetically modified crop is that you do something to the genes or the strains of a particular crop, and the hope is that you get a bigger yield, you get a bigger product, you get more yield per acre, whatever it happens to be. But the biotechnology is important. And there have been some stunning changes in the food production around the world based on the genetic modification of food and the biotechnology. And as I said, there are concerns, but we'll talk about those in a later class. The hope of the biotechnology is that, for example, if you're having to put pesticides on crops because bugs are eating up the crops, there are several downsides of that. One is that it costs the farmers money, and farmers in lots of parts of the world don't have the money to spend on the pesticides. But also there's environmental concern about what pesticides are doing to groundwater, et cetera. So if you could develop a strain of crops that themselves resist the pests that used to feed on them, then there would be advances from that. This would, of course, decrease the loss from pests and disease. So not only would pests be a problem that the crops, genetically modified crops, might help fight off, but also things like blight and other forms of disease like that. Crops are very often under stress. So for example, if there's too much water, you all probably remember the big floods in the Midwest that happened within the past several years, and a lot of the farmland was underwater at that point. That stresses the crops. Drought, of course, stresses the crops. The changes in the acidity or the salinity of the soil stresses crops. Possible you can genetically modify the crops to resist those sort of stresses. There is some hope that you could genetically modify crops to increase the nutrient yield from them. So if you grow a carrot traditionally, or you genetically modify a carrot, would the genetically modified carrot have more vitamins, minerals, or whatever in it, and give more nutritional punch per carrot? And those are the kind of things that the genetically modified food advocates believe can take place. Now, there are some concerns, especially among people who are proponents of sustainable agriculture, and some data to suggest that, at least in the United States, that the crops that are coming from the big factory farms tend to have fewer nutrients than things that are grown locally and organically. Now, there's not a lot of research on this, but some of it suggests that the locally grown, organically grown crops have more nutrients given whatever they're in. But again, that's somewhat controversial. But this would be the hope, and then of course to push up the yield would be a very important thing to do. So an example would be genetically engineered rice. And so there's a particular strain of rice with something called the Bt gene that has been used quite a lot around the world. And it's been designed to resist certain insects, these types of borers that you see here, all of which feed on the rice. And so scientists have gotten involved, genetically modified the rice in hopes of making it less attractive to these particular pests, and therefore decreasing the opportunity for these pests to interfere with yield. Here's an example, a photograph of a field test of these sort of things done in the Philippines. Here would be an example in China where there are treatment or genetically modified versions of the rice next to control versions, so the non-genetically modified rice. So that would be the T and the C. And so you see here, you know, in a very nicely done experiment where you have one set of crops grown right next to the other, it's a controlled experiment, you see the higher level of green and therefore yield and productivity in the ones that are genetically modified. Here would be a different example of things grown in smaller furrows next to each other with treatment and control, and then you see it like this too. So some of the best done science, the best controlled studies, the best methods for doing research started out in agriculture, and there ended up being controlled experiments like this where you use different sorts of varieties or strains of rice. And so you can see in this case that the treatment, the genetically modified ones are doing better than the control ones. So the overall impact of the genetic modification of rice has been 28% higher yield just from this one particular genetic modification of the Bt gene. So that's a pretty impressive increase. Cotton becomes another very interesting player in this, and I'll use this as an example. And there are large parts of the world where cotton is pretty darn important. So 60 million people dependent on cotton for their livelihood just in India. There's this insect called the bollworm that creates an awful lot of damage, and the losses in just China and India are estimated to be this large. And the cotton crops around the world take half of all the pesticides that are being used. So the millions and millions and millions of gallons of substances that some people worry are toxic are being used to keep this particular worm from eating the cotton. So if that can be decreased, the cost to the environment may be less. So here would be an example, a picture of BT cotton that's been genetically modified. The particular strain of cotton, in these things, when they're genetically modified by scientists, they become valuable properties for the companies who've done the genetic modification. They own the intellectual property, that is the DNA of those particular crops, and then they sell them into the world market. Now, some people that are concerned with social justice, and we'll loop back to this later on, say that this is blatantly unfair, that you simply cannot patent food that's necessary to feed the world. And there was a quote that I showed you from Margaret Mead a couple of classes ago that talked about considering food as a product, a profit opportunity, a commodity, rather than a substance that we just have to give to people. And that conflicts, that sort of philosophy conflicts with a company's, in some people's minds, legitimate right to invest money in the science that creates these advances, and then they should be able to profit from it. So again, it depends on your perspective on that. But the Monsanto company, which is headquartered in the Midwest, is probably the biggest player in the genetic modification of foods. And we'll talk a little bit more about Monsanto down the road. But they have created a type of cotton called Bollgard, and I'll come back to the Roundup Ready and what that means in a later class. But they have created this and then benefit financially from its creation. So here's an example of what the worm can do to cotton and the need to do something about it. And so the Monsanto Corporation, in its own public relations, talks about the benefits of the reduced pesticide use with the use of the genetic strain. So what they say is that, yes, we sell it for profit. Farmers have to pay us to use this particular seed. And the company has and other companies have very interesting ways of enforcing who uses seeds and who doesn't. Because you think it'd be pretty easy to go sneak some seeds, keep some on your farm from the last crop and replant it the next year. But the company has interesting ways of monitoring that to protect their profits. But what they say is, yes, people pay for this, but they more than get return, not only from the productivity, but the environment also benefits, because there are places where you're saving fuel. So, for example, they calculate the number of millions of gallons of fuel that they estimate are saved because you're not using fossil fuel, for example, to make the pesticides. You're not having to ship them in containers across the world to deliver to the farmers, which has an energy cost as well. And that all you need to do is give people the seeds or sell them the seeds. And so they say that overall the calculus argues very much in favor of using these things, even if it's the environmental concern that you have, that you're better off having these things than not having them. Now again, this is public relations from the company, so each person has to come to their own conclusions about how much you trust their numbers or trust the philosophy or what they might be overlooking or hiding, et cetera. And some people trust these industries more than other people trust these industries, but this is at least what the company has to say. So it's been estimated that 2 million gallons of pesticide use just in the US is prevented by the use of BT cotton, and that in South Africa there was a 20% increase in yield, and it led to 6 fewer pesticide sprayings on average for farms. So these are pretty impressive numbers, good yields, and the cost benefit is interesting to calculate in these kind of cases. Another very interesting example is a type of rice called golden rice. And if you go into the Google and you Google golden rice, you'll see all kinds of stuff on both sides of this issue. Golden rice is good, golden rice is terrible and dangerous and all that sort of thing. But let me tell you what it is. There was an article about this in the journal Science where the authors talked about what golden rice is, what its genetic makeup is, and how it might benefit the world. And there's this particular fellow in Switzerland named Petrikis who is credited with the discovery of golden rice. And he has talked about the impact that this can have on world rice production. And so, as you see over here under the banner headline, this rice could save 1 million kids a year, but protesters believe such genetically modified foods are bad for us and our planet. Here's why. So right in this one issue of Time magazine, you see the potential downsides of the genetic modification and the potential upsides. So the golden rice in particular is important for these reasons. As you might know, of course, rice is a particularly important crop for the world and for its food supply. It contributes 1/5 of all the world's calories. Milled rice, which is the most common consumed, has no vitamin A in it. And I'll come back and talk about a major public health victory in a subsequent class about fortifying diets with vitamin A and what that's done, especially to prevent blindness. There are many millions of people around the world who are vitamin A deficient, and 500,000 of these go blind every single year. So the possibility that you could have a different strain of rice that provides more nutrients, particularly vitamin A, and potentially more yield at the same time is extremely appealing. And so here's a picture of traditional rice versus golden rice. The hope is that it could resist deaths, but as we said, there are many protests, and it's probably years away from heavy use in the actual marketplace. When we look at rice and biotechnology in general, and the green revolution in general, better pesticides, fertilizers, all these sort of things, it's interesting to see what happened. Now, we showed the increase in productivity for tea just from the irrigation, but this will be how much rice productivity has increased around the world. So from 1966 to 1996, this is the percent increased rice production in different countries. And you can see the lowest increase is in China, and they almost doubled rice production during that period of time. Now, of course, the population is growing. There are more, during that time, there are more people engaged in farming, perhaps more land, although I'm not certain of this, in use for rice production. So some of this increase would be attributed to those, but some certainly to the Green Revolution. And then when you look to the other countries, you see in Indonesia almost a tripling of production of rice during that period of time. So these are the kind of numbers that the proponents of the Green Revolution point to as evidence that it works, that we do it, we invest money, it's worth investing the money because these are the sort of products that you get from it. And the world simply can't survive unless we do more of this kind of thing. So there's a strong argument in favor of it. Here are a few other examples with other crops on how productivity has increased. So a 20-year period alone from 1950 to 1970, you can see how much the productivity and production of wheat was accomplished in Mexico. And remember, this was Norman Borlaug's work, giving the Green Revolution in New Mexico, especially focusing on wheat. Here's annual tons of wheat, the increase in the past 50 years from 6 to 82 million annual tons, a remarkable increase in that period of time. And then if you look just at the various types of food around the world during that 40-year period, the number has gone way up. So it's pretty hard to argue with the idea that the Green Revolution has greatly increased how much food we have available. It certainly has. Here's another graph showing coarse grain production beginning in 1966 and then going up to more or less the present time. And it's just a very steady increase. So even the people who oppose the concepts of the Green Revolution on the basis that it's doing more harm than good can't dispute numbers like this because it's been shown in country after country with crop after crop. Here's yet another example from 1950 to 2004. These are the yields in wheat in developing countries. So this isn't the total production of wheat. This is the yield per unit of area. So this is the yield in kilograms of the crop per hectare that I mentioned before. And the yield has gone up and up and up and up. And that's a pretty impressive increase. And this is in the developing countries where you'd most need to see this kind of thing. So this is reason to celebrate, no question about it. And as the world's population continues to increase, exactly these kind of changes need to happen. Now, there are downsides, as I mentioned. We'll talk about those later, but there are clear upsides, and you see evidence of it right here. So the overall impact of the Green Revolution has been interesting. Large increases in the world food production. The most recent estimates are that famine around the world has been decreased by 20%, and that there has been a 25% increase in per capita calorie intake. Now in the United States, that contributing to that number is not such a good thing. But around the world where people are undernourished and they need more calories to survive, this kind of an increase is pretty impressive. And if you think about what the Green Revolution would be fighting against, pests, blights, other types of diseases, politics, war, refugees, all sorts of those things that would make it difficult to change the world's food supply, the Green Revolution in many ways has prevailed nonetheless. And part of it is because it's been funded by the Rockefeller Foundation that's been particularly aggressive at pursuing the Green Revolution. People in certain countries have been wise enough to take this on as a cause, and as a consequence, there's been a big change in the world food landscape. So that's really up until now, this is phase one of the Green Revolution. So if you talk about the Norman Borlaug type of things that began in the 1940s, up until fairly recent time, what I've just shown you is the picture. Genetic modification, irrigation, technology, pumping, you put all this together, yields have gone up, the amount of farming has gone up, and the productivity of the average farmer around the world has gone up. And so this is good. In fact, it's pretty darn good if you look at it. But there have been some challenges. And so there have been concerns raised that the plateaus in yield are beginning to occur around the world, and maybe we've hit an upper limit with that. Maybe we simply can't put in more fertilizer. We've done everything we can with pesticides. Maybe there are genetic modification advances yet to be made. There probably are, but the plateaus in yield are concerning, and there are not plateaus in the growth of world population. As I mentioned earlier, there's grave concern with the relatively small impact of the Green Revolution in Africa. There are a number of reasons for that. Among them are the special climate issues in Africa, but also the instability of the governments in those countries, the corruption, and the vast amounts of poverty in those areas have made it difficult to have an impact. The fact that these technology advances are available doesn't necessarily mean that farmers around the world can afford to use them. And when they can't, the Green Revolution is essentially lost on them. But they have to compete in the world market to the extent that they're involved in commerce with their agriculture with countries like the US that are producing vast amounts of crops, subsidized in part by the government, fueled by technology and the use of the things that the small farmers can't afford themselves, and therefore they end up in a disadvantageous position, and this affects their livelihood and their ability to survive as farmers. Environmental problems I'll bring up more in a subsequent class. There is talk about the fact that the world has limited land that can be used to raise crops, and we might be approaching the maximum use of that. There's also concern about increasing meat consumption around the world. And I'll show you some figures later about the amount of energy that it takes to produce meat. And so more or less the way it works is that if you're eating meat, it means that you're paying for, or somebody is paying for, the land, the grain that gets used to feed the animal, and then you get meat from that. So let's just say corn goes into feeding a cow, or other grains too, but let's just take the corn as an example. Humans could eat the corn itself, or the corn could get fed to a cow and then humans eat the meat that comes from the cow. There's much efficiency lost in eating the meat that comes from the cow, and much more fossil fuel energy involved in that transaction than if people just eat the raw product themselves. And so the fact that the world consumption of meat has gone up, fueled in part by booming economies. So take a country like India, as you heard from that NPR clip that I showed you before, the economy in India and the economy in China. The economies grow and prosper, and that's all good for those countries in some ways, but it also changes diet. And to the extent people are eating meat, that decreases the world efficiency in growing crops because of that conversion that I mentioned before. And so there is grave concern that population will overwhelm the food supply. Most everybody who has made projections on this that I have seen have estimated that we're going to run out of food at some point. That we simply can't, with technology, increase food production enough to keep up with the world increasing population. The estimates differ on when that will happen. And I've seen estimates that say that we're probably okay at least until the year 2050, but then we really have to start worrying. But of course, a lot could happen between now and then, but those are what some of the estimates are. So this raises to another level the stakes of increasing world food efficiency. And that means there has to be a phase 2 of the Green Revolution, which some people are talking about. And you start to see this get covered in the popular press, but a lot in scientific journals and in reports by world government agencies. So here would be an example of that. In 2007, there was a report that said there was a warning issued that the global food shortages that were being alerted to by the Food and Agricultural Organization would lead to a surge in grain prices, fueling the food riots in developing countries, which we've now seen, where the population spend 80% of their income on food. Now in the United States, I don't remember the precise numbers, but what people spend of their income on food is a really low number compared to what you see here. So the International Herald Tribune talked about how the Green Revolution is falling short, even in India, where there have been some major advances. So this says that with the right technology and public policy, economists say India could help feed the world. Instead, it can barely feed itself. So the question is, has phase 1 of the Green Revolution done its job in India, or is more necessary? So there is now discussion about bringing the Green Revolution in greater ways to countries that have already benefited from it, but especially focusing the Green Revolution in phase 2 on Africa. Okay, so this particular quote from this article in the Times: even the most promising new crop varieties will not by themselves bring the plentiful harvest that can end poverty. New ways to get seeds into the hand of farmers are needed, as well as broader investment in the basic ingredients of a farm economy, roads, credit, and farmer education, among others. So you can see the number of factors that are involved in doing something about this. Here's what's happening with this. There is a group called the Alliance for a Green Revolution in Africa, whose head is Kofi Annan, who's the former head of the United Nations. This particular alliance was established as a joint effort by the Rockefeller Foundation, as I mentioned before, the major player in this, and then the Bill and Melinda Gates Foundation. In 2006, they announced this alliance to help deal with the Green Revolution. Now, this was a major advance for several reasons. First is the attention of the Gates Foundation is pretty darn important here. They're by far the largest foundation in the world. Rockefeller, as big as it is dwarfed by the size of the Gates Foundation. So if Gates pays attention to you, that's good. And Gates started paying attention to the Green Revolution. The fact that they went into connection with the Rockefeller Foundation was a good thing, because the additional resources and all that experience of the Rockefeller Foundation makes for a pretty good combination. And foundations don't always work together very effectively, so this is a credit to the people who spearheaded this effort. And as you can imagine, it was probably Bill and Melinda Gates themselves, and then Judy Rodin and others from the Rockefeller Foundation. So here's a document that has been created to talk about this particular African Green Revolution. There was a meeting in Bellagio, Italy, that was where the Earth Institute at Columbia University was heavily involved in 2008. And this particular document, if you care to read it, can be obtained from the web. But it's very interesting and points out the need for doing things in Africa, and also starts to provide a blueprint for what might be done there. So what's the next generation of the Green Revolution? Where is it going to go? Well, this is the Rockefeller and Gates Foundation coming together. If you'd like to hear about this or read about it, I've given the website for the announcement, and there are a lot of resources on this at the Rockefeller Foundation website, and also the Gates Foundation has information on their website. And I've given links to 2 good NPR clips on this that talk about the Green Revolution. Now, I'd like to play you this particular clip from NPR about the Green Revolution, as I feel it's really pretty interesting, pertaining to the discussion we've just had. And sorry for the initial little ad you have to listen to.
Support for NPR comes from Verve Forecast, presenting British songstress Beth Raleigh with her debut album, Little Dreamer, available now.
The Bill and Melinda Gates Foundation said it wants to bring a revolution to farming in Africa, and it's joined forces with the Rockefeller Foundation to do it. Together, the foundations say they will spend hundreds of millions of dollars to put new technology in the hands of African farmers and help those farmers get better prices for their harvests. Dan Charles reports.
Annette Namayanja works with bean plants at the National Agricultural Research Organization in Kampala, Uganda. In March this year, she got a special invitation from the Rockefeller Foundation, which helps fund her research. Would she travel to Kenya to present her work to visitors from America's wealthiest foundation? That's where Namayanja met Melinda Gates.
At first we thought we were going to meet Bill Gates. Then we later realized we're meeting the wife. Then we're like, wow, this is a very interesting opportunity for some of us.
Namayanja told Gates how, through careful selection and cross-pollination, she'd created 2 hardy varieties of beans. These plants fend off a disease that rots away the roots of most other plants. And another plant breeder, Jane Ininda from the Kenya Agricultural Research Institute, showed Gates some new varieties of corn that produce good harvests even when there's not much rain.
One of the questions I remember she asked me was, how do you get the product that you have to the farmer? Because you know you can have the product on the station, but how does it get to the farmer?
Melinda Gates must have liked the answer. During a conference call announcing the new initiative, she called Jane Ininda a shining example of people she met on that trip who are bringing new energy to agriculture in Africa.
And I came away convinced that they hold the potential to significantly improve the lives of the people of Africa.
Bill Gates said their foundation decided to launch a program on agriculture in Africa because of the simple fact that most Africans live and work on small farms. Give them the tools to increase their harvests and make more money, and it will transform their lives.
So I want to stress that this is a long-term effort and one that we hope will not only dramatically increase agricultural productivity, but also move millions of people out of extreme poverty and reduce hunger.
The foundations are calling it an Alliance for a Green Revolution in Africa. The Rockefeller Foundation played a big role in the original Green Revolution, which started 40 years ago. It funded plant breeders who created new, highly productive kinds of wheat and rice. Asian governments distributed those seeds to farmers across the most fertile parts of the continent, provided irrigation, and made sure farmers had access to cheap fertilizer. Food production in Asia doubled, and one of the plant breeders, Norman Borlaug, won a Nobel Peace Prize. But the Green Revolution never happened in Africa, despite 40 years of trying. It's the only continent where food production per person has actually been falling. There's a long list of reasons. Karen Brooks, who manages the World Bank's work on agriculture in East Africa, says to start with, African farmers don't depend on just a few crops like wheat and rice.
You've got bananas, you've got sweet potatoes, cassava, you've got livestock.
Geography creates other problems. Michael Morris, an agricultural economist at the World Bank, says African farmers are scattered across vast areas, often far from decent roads. That makes it difficult for them to get fertilizer, which fueled the Green Revolution in Asia.
By the time fertilizer reaches farmers in Africa, they're paying prices for it that are often multiples of the prices that farmers in other parts of the world would pay.
That isolation also means when farmers do get a bumper crop, they often don't get much money for it. They have to sell their harvest at local markets for rock bottom prices, even though it might fetch much more, just 50 miles away. Because of all those problems, Morris says, many people lost patience. Funding for agriculture in Africa stagnated during the 1990s. But now he says people are realizing there's no way around it. Prosperity in Africa will have to start where most people live, on the farm. And now the Gates Foundation is on board.
People are coming back to the realization that we've maybe neglected agriculture a bit for a while. We really need to figure out how to solve some of these problems.
The two foundations will spend $150 million just on seeds over the next 5 years. They expect plant breeders to develop hundreds of new, better varieties of corn, cassava, and chickpeas, and they'll help get those seeds to farmers. Down the road, they'll try to jumpstart fertilizer distribution. And in a slightly high-tech experiment, they'll expand small programs in Kenya and Malawi that use cell phones to exchange information about prices in different villages. That way farmers will have a better idea where they can earn the most money. The foundations wouldn't say how much they intend to spend on all those efforts. Bill Gates said it will depend on their results. For NPR News, I'm Dan Charles.
So a lot interesting was woven into that particular clip. The case of the woman who had developed the strain of beans is interesting because there are some concerns with American companies in particular, but other companies around the world, taking strains of crops that have been in families for years and years and copyrighting the genetic material in those, and then local farmers may have to buy the rights to use the very crop that they've been using in their families for years and years. We'll come back to that a little bit in the end as well. So overall, the Green Revolution has been a stunning success in some ways, been disappointing in other ways in certain parts of the country, but certainly is an interesting and controversial issue. So as I said, we talked today mainly about the upsides of this, the great increases in yield in certain parts of the world, and we'll talk about some concerns about it later.